Hello, everyone. Welcome to the first Bevy Meetup of 2026. And I'm super excited to be back. We had a few months of a break, and we are kicking off the next season of the Bevy Meetups. Excuse me. And the show must go on, right? So I'm really excited that we just saw a super big Bevy release, and we are going to talk about two super exciting topics today. So let's get right into it. We have two amazing speakers today. The format is, as usual, 15 to 20 minutes presentation. You will find a live Q&A platform behind the QR code to interact with the speakers. And there will be time after each presentation. And at the end, we will do a little panel conversation with both of them. Everything will be recorded, and you see it live on stream now. So you can always catch up later as well. Code of conduct, as usual: be kind, be respectful, be curious, and reach out to me if you have any concerns. Don't hesitate about that. Who am I? I'm Stefan. I'm doing Rust since 2017, 18 years of game development. You might know me from open source tools written in Rust like Git UI and LifeAsk. And I founded Rust Unit. We are building games with Bevy. And feel free to check us out on rustunit.com. Here's the QR code again as a reminder. Feel free to drop anonymous questions in there. Anything is fair game. We want to have a very open conversation here with everyone. So without further ado, let me actually put my slides away and get our first speaker on stage. Welcome, Promethea.
Hi.
Let me put your slides up here, and then the stage is yours. I can't wait to learn more about dependency injection in Bevy.
All right. So I'll be talking about dependency injection in Bevy. You may recognize that phrase because I have written a book on it, and it is fairly popular, linked around in the Bevy Discord a lot. I'm a sort of general game programmer and an amateur language developer. I'm interested in a lot of different technical topics, so I kind of bounce around. I've done graphics, I've done networking, I've done language design. I've been using Bevy since about 0.6 or so, and I'm also the developer of an old character controller crate called Bevy Mod Wanderlust, if anyone remembers that. It's defunct now, but as far as I know, it was the first character controller crate. So to get started, what is dependency injection? Because I think a lot of folks don't really recognize fully what it means. A lot of folks have heard of it from Java or C#, and usually the opinion I see is that it's kind of archaic, verbose, unnecessary, maybe performs badly, which isn't necessarily true. That can be true of implementations, but it's simpler than you think. You can see in the image, or the screenshots, it's essentially, without dependency injection, you are calling functions manually. With it, you are adding them to some framework or app, and the app calls them for you. So dependency injection just means automated function calling, where parameters are retrieved automatically and functions are called precisely when they're needed. This gives you a lot of different benefits, and the interesting part is how it's implemented, in my opinion. Usually, most languages use runtime reflection. So for example, Python, C#, Java, they all just use reflection, and usually they have an attribute system so they can read some extra data applied to different types and functions. Reflection is reading the metadata of a program at runtime. So you can read things like the syntax, the type names, the arguments that a function takes, and usually you can even take that information and start doing things dynamically that you wouldn't normally be able to. It doesn't perform very well because it's so dynamic, but it is extremely powerful. You can also technically do it at compile time in certain ways, but that's a pretty recent development, and not a lot of languages have that. It does allow metaprogramming at runtime, which is kind of unusual. In this picture, you can see something you can do in C#, for instance, where you load an assembly and then read out all of the types and their names at runtime, which is not something you could do in, say, Rust or C or C++, because they just don't have that information available. Although I think C++ specifically does have a mechanism called runtime type information. So why would you do dependency injection? What is the point? It gives you certain nice abstractions, like you can change system signatures without changing the call site. So you just refactor your system and then it just works. The parameters will be provided automatically and you don't have to go tie things up somewhere else, which can be really nice in a large code base where now you don't have to jump around and fix up everywhere that that function was touching. It also allows the app to manage the control flow automatically. So things like automatic parallelization or setting up data-driven execution by reading from config files become possible because the app is handling it, so you can automate it. In Bevy specifically, this is what dependency injection looks like, is right at the beginning when you're assigning systems, that is dependency injection. Specifically for this talk, I'm worried about the tuples of systems themselves, not the plugins or the schedules. Those parts are not as specific to what I'm talking about. So I talked about how usually it's implemented using reflection, and Rust does not have reflection. Yet, technically, Rust just merged a little bit of compile time reflection onto the unstable branch, but it's not really there yet. So if it's not there yet, what is Bevy doing to make this work? It isn't reflection, as I said. It's not Bevy Reflect either. Bevy Reflect is a crate developed by Bevy to implement runtime reflection. And it does so using macros. Essentially, it's just macros that read your code and generate a bunch of access functions to read information generated from the code, which is limiting because it means the macros don't have access to type information. And also, you may notice the systems themselves don't have any like proc macros attached to them. So it isn't Bevy Reflect. It's just Bevy Reflect is not relevant to the ECS in that way. Rust's type system is the key, specifically the function traits fn, fnbut, and fn_once. The key insight is that every function or closure gets a unique type generated for it. So you can see here, if you were to define two functions, foo and bar, doesn't matter what parameters they take or return, if you get their type IDs and compare them, they will be different, and you can do that. That type implements some of the function traits. All of them will implement fn_once because every function can be called at least once. Closures might not implement fn because it needs mutable access, but a basic function should implement all three. So through that, we can get a type for every function and do some logic on it using traits. Next, we have to select a specific function implementation for a type by wrapping it in a struct, which is due to type system complications, because technically any type can have multiple trait implementations, and that means technically a function could be two functions with the same type. They probably won't be, but if a user defined a type and implemented the function traits manually, it could be, so we have to handle it. Type inference and trait inference can help deal with that later. So then we implement system for that struct and store it in the schedule to run later. And the system implementation automatically retrieves arguments from storage and passes them as arguments to its run implementation. So next I'm going to show and walk through some code from my book to illustrate this idea more clearly. So don't get too overwhelmed. I'm going to highlight specific parts at a time. This code implements system for functions with one argument. Any static type can be a system parameter, and the global storage is just a hash map of values, one of each type, instead of an ECS world, just for simplicity. So first, we define the system trait. All the system trait does is it takes in the system itself and then some resources, and it will automatically retrieve values from resources and call itself. This is what lets us dynamically call systems without caring what values they take. Next, this is the struct wrapper that we use to select a specific function implementation. So if you had implemented a type with 2 different functions, this is what lets us select a specific one. And this is because if we blanket implemented system for functions, it wouldn't know which one to pick by default, and then the implementation would fail. So that's what this is for. Kind of complicated type system stuff, but it is necessary. The struct manages to select a specific implementation because it is locked to a specific set of generic arguments. The input parameter is the arguments that are passed into the function. That means there can only be one matching function implementation. So then everything works. And if you only have the one function implementation, the type system will just infer it, so you don't need to specifically construct the function system. And the phantom data is needed because the input parameters are not otherwise used, so we just need to put them somewhere. Next, we implement system for the struct wrapper, which is the function that automatically retrieves data. You can see it removes from the resource cache and then downcasts and unwraps and passes it into its own function. In an ECS, this system could be more complicated. You might, for example, do some query logic here. For this example, it's just accessing a basic value from a hash map. And then finally, we define some helper into system traits to wrap the system. This lets the .add system function on app take a system directly instead of a function system. It technically isn't necessary, but it means we don't have to manually wrap every parameter in a function system when we're just trying to set up the app. Bevy's benefits from this, I think Bevy gets a lot out of dependency injection. I think it fits very well. Firstly, app definition becomes declarative. You don't have to manually set up a run loop and call all of the systems in your app in a row. You just can outline, I want this to happen, then this to happen, then this to happen, and then it will happen in the order you declared. It also lets you, like I earlier mentioned, refactor by just changing a system, and you don't have to worry about the parameters getting passed around somewhere else. The app will take care of it. It also allows you to do really cool things like hook into system sets that were defined elsewhere by using system labels and before and after, and just hooking into third-party crates or Bevy's own systems and adding logic where there was none. But there are also some drawbacks. One of them, the compile time hit, I outlined in the latest chapter of my book. I found that there was some overhead and compile time using this trick. If you were a library designer and you're thinking about using this for a library you're developing, I would ask that you consider if it will really help benefit because of this specific issue, the compile time hit. It can be pretty severe, from what I can tell. And also, it's not strictly necessary that you use dependency injection. You could just ask users to call their systems themselves. And depending on your project, the benefits might not be that much. It is also very complex for new users. Often we would see new Bevy developers join the Discord and ask, like, how does this work? It literally looks like magic. What are you doing? And a lot of times folks would ask, like, is this based on Bevy Reflect? Is Bevy Reflect doing some magic behind the scenes? They just wouldn't have a mental model of what's going on, which just makes it very confusing and feel weird to use Bevy. So that's why I wrote my book in the first place, was I understood how it worked and I wanted to help others understand how it worked. And now I'm giving this talk for the same reason. It's also pretty complex to develop and maintain. I mean, you saw the code. It's kind of a lot of hoops to jump through for I want in a loop for me. Bevy gets good mileage out of it and has enough contributors that this is worth it. But if you are a solo dev or a small team trying to work on something, that's a lot of effort to put on for something that is not strictly necessary. So again, just consider, is it really worth it? Are you actually going to benefit enough to be worth implementing something so complex. So with that, does anyone have any questions for me? Although, are we doing question section later?
Yes. Thank you so much, Promethea. I'm super excited about this topic myself. This is one of those black magic parts of Bevy. So it's always appreciated, people like making this more digestible and understandable. This was really insightful. Yeah, we have a bunch of questions. Let's actually go through some of them. What would a next generation dependency injection look like in Bevy? Are there potential improvements that would be V2 level changes?
I don't think so. I did have some ideas for how to mitigate the compile time hit without changing the API significantly, which would be adding a macro and having the macro generate code that is much less compile time overhead. So essentially, that would just be adding a system macro on your systems. And I figured out a way that you could still have systems without the macro. It would just help compile time to put system on things. Other than that, I haven't thought of any ways to make dependency injection significantly better. I feel like it's kind of already at a local maxima of like, it's very slick and clean and it just works. And I guess the other thing would be better errors, but Rust did add those better lints that the Bevy developers can customize. So the errors already got a bit better, but we'll see.
Is the system macro that you talked about, is that something that's going to be upstreamed at some point?
Maybe I'd have to go back to it and refine it. Currently, it's just an idea, and I'm somewhat short on time to work on something complicated like that, but I'm interested in seeing where it goes.
Yeah. Okay, that's super cool. Wait, where was the next question? Is there anything in progress in Rust itself to improve the compile time impact?
Nothing super specific, except that variadic generics is a feature that could lead to an improvement, because currently internally Bevy uses macros to generate implementations for systems with no parameters, systems with 1 parameter, system with 2 parameters, and so on, up to like 8 or 16. That causes a lot of compile time impact. Variadic generics would let us just define a trait once for systems with any number of parameters. That could maybe help compile times. Not clear yet. It could also make it worse depending on implementation. I would like to see it make things better. I think it would not be worth using if it made things worse, but yes. Hard to tell. It's not implemented. I'm very excited to see when variadic generics get merged.
Okay, so there's not even like a feature flagged nightly implementation or whatever?
I don't believe so. Maybe I just missed it, but.
All right. So the next question is, you pretty much answered already, because it's about the impact on compile times. But maybe there's like a short summary. Like, is there any way to measure this that you can talk about here without having to read the last chapter of your book?
So essentially, what I did for the last chapter of my book is I generated just a simple file that was a ton of functions and adds them to an app and sees how long that takes to compile, versus what if I just called all of the functions in a row manually and see how long that takes to compile. And through that, I found that just calling all the functions in a row, pretty much instant, adding them all to the app takes a long time. That was the key insight of like, there is overhead here. I don't think it's as exaggerated as in my example, because it's specifically making it as bad as possible to see if there's anything there. Harder to measure on an actual application, for example. Like, it'd be hard to look at your actual compile times and be like, oh, 5% of this is Bevy overhead for dependency injection. Like, that's harder to measure.
Yeah. Fair enough. I mean, the second part of this question is also talking about generated code size. I don't know if that's really something that it's equally hard to probably compare, right?
Here, actually, so in terms of macro output, there's not a lot because you're not putting it on every system. It's just inside Bevy, they generate a couple implementations. So that part isn't too bad. In terms of like generic monomorphization, so the actual final every system's generated code that goes into the binary, that I found does look like a good place where there might be a lot of overhead coming in. The system itself probably isn't changing much because it's still just a normal function, and a good amount of it is dynamic. But specifically, I think there were a couple functions that get called in the add system call path that were generating a lot of hits in LLVM lines. I forget exactly what they were. I think one was related to debug printing. So I'd measured that. I'm not sure if it's actually relevant to compile times, but it did seem a little concerning.
Okay, I see. I'm not sure if you touched on it. I mean, in general, you said it's maybe not the right tool for everything, but the next question is about, can Bevy's DI be used in regular Rust applications?
In terms of using the technique, yes, you could apply the same technique. For example, Axum does use the same technique that I'm aware of. Bevy specifically, the implementation is kind of built into the ECS itself, I think. Or I think it's split between the ECS and the app crates, technically. I have a hard time seeing you use those without essentially using Bevy itself, because that kind of is the core identity of Bevy. So I don't know if the implementation is very reusable without basically using Bevy itself.
But I guess there is cases where people are using those things for let's say, game or interactive use cases. At least I remember some like static site generation, I think, was prototype using it. But it's not like wildly common, right?
You can definitely use Bevy itself for non-game or non-interactive applications. For example, I believe Foresight Mining Corporation or Foresight Labs, I'm fairly certain they use it a lot for things that you wouldn't call a game.
No, I mean, I was really thinking more of the really wild use case, like the static site generation, which is not even like interact or not.
Yeah, I hadn't heard of that. That is really out there. I did once try to experiment with using it to build a compiler. I didn't like it very much, but it was interesting.
Actually, one question that since you pointed out where it's sort of the core of the Bevy engine itself, did you also familiarize yourself with other dependency injection implementations in Rust that you can compare this against?
The only one I'm really familiar with is Axum, and I haven't used Axum or looked into it in depth.
It's using a similar approach, right? Axum,
yeah, I believe so. Same idea of using traits to detect function implementations and automatically wrap them and such.
Yeah. All right. Let's do one more before we maybe delay the rest for the end. How does the black magic of parallelizing non-overlapping systems work under the hood?
Okay, so that is a fair bit more complicated, in my opinion. But the basics are Bevy can look at a system's parameters and create basically a checklist of every resource, including entities, that system accesses. And then it can just diff that against other systems very quickly using a bit set and go, okay, so this system and this system do not conflict, therefore they can run at the same time. And it will just hand them to the scheduler to run at the same time. If they conflict, it has to generate a boundary between them so that they run serial. And then it hands that off to the scheduler and says, these have to run one after the other. Very, very high level overview of how it works. But that's the basics.
And where do commands get triggered in this chain of events?
That changed enough times that I don't even fully remember. currently, there is a system label called apply deferred, if I remember correctly, and it is also automatically inserted. I think it was between systems where one system uses commands and the next system requires anything that that system was asking for. At this point, I don't know if it maybe is finally settled on just apply commands immediately.
But it would be a barrier as well where no other system can run at the same time, right?
Yes, every time you apply systems, the entire world has to sync down to one system running to apply commands.
Yeah. All right. Cool. Well, thanks again, Promethea, and everyone in chat. Please give a big hand for this super interesting presentation. And let's reserve some more time at the end for some of the remaining questions and maybe more that come up in the meantime.
Cool.
Thank you. All right. Well, let's get ready for our second speaker tonight. You might be familiar with their work. It is one of the big networking crates that we have in our ecosystem. So let me introduce you to Periwink. Here you are, and let me get your slides as well so that you can kickstart it off. Thank you so much for being here, Periwink.
Yeah, sure. My pleasure. So this is Periwink on Discord, and I'm going to talk about Lightyear and how to do multiplayer games with Lightyear. So a little bit about me. I've been involved in Bevy since 2023. I was mostly interested in the ECS originally, and then shifted towards mostly working on the networking side of things. I'm French. I live in New York. I work as a software engineer in a trading company. And I'm a cat dad for a cat called Ollie. This is actually my profile picture on Discord. And I've had actually like at least 5 different people ask me if this was some kind of spider monster, but it's just my cat in reverse. So yeah, nothing to worry about here. So what is Lightyear? So it's trying to be a comprehensive networking library for Bevy that can basically sync data between multiple peers, sync their Bevy timelines as well, exchange messages between those peers, handles input replication. So when you're pressing some buttons, send those inputs from the client to the server. And it can do so by defining your own inputs, but it's also compatible with Livewing or Bevy Enhanced Input, which is like the latest input library for Bevy. It supports 2 types of replication, which are basically the 2 big paradigms of networking. So one is state replication, where you're directly replicating the state of your world, like you're serializing your entities and resources and sending that to the remote peer. Or deterministic replication, where you're just sending the inputs, like which buttons you're pressing, and the remote peer that receives the inputs can reconstruct the state of the world perfectly if the game is deterministic. And it can even do a mix of both, where, for example, the game is deterministic, but when a new client connects, you start by replicating the state of the world, and then you continue by using determinism. And it also has a lot of advanced features that are needed for fast-paced games. So prediction, visibility. So visibility is like sending data only to a subset of clients, delta compression, etc. And I'm going to show and talk about these later. So what is the architecture? I guess the key insight is that each peer, so peer is basically like a client or a computer connected to the network, is an entity in Bevy. And this is really powerful because it allows for a flexible topology. You can have multiple clients, multiple entities inside your app. You could have multiple servers. It can support both a client server or like a peer-to-peer architecture. And then once you have this entity, you can add extra components to tell Lightyear how this peer behaves with the rest of the network. So the main component is the link, which represents basically a link between 2 different computers on the network. And this is what's used to send and receive raw bytes. And there's extra metadata components that can be added. So you can tell, what is the local IP address of the peer, what is the remote address of the peer that you're connected to. There's the same with IDs. So Lightyear assigns like a unique ID to each peer connected on the network. There's also the role. So you can have you can be a client, a server, a client of a server. So yeah, the name is a bit confusing, but it's basically just the client that is controlled by a given server, and even a host client. So that's when a client acts as both a server and a client in the same app. There are some components that track the status of a given entity, so of a given client or server, like are we connected, is the server started or stopped. You can also add components to define like how the bytes are going to be sent across the network. So are you using UDP, WebSocket, WebTransport? And yeah, I think that the Bevy ECS is pretty powerful because it allows you to be very flexible in the capabilities that you add to each of these peers, using ECS and components. So one of the big things that Lightyear handles for you is syncing the timeline between the local computer and the remote computer. Because in multiplayer games, there's always multiple timelines involved. And there's basically 4 big ones. So the local timeline, it's what Lightyear uses to track time in general. And basically, it follows the time resource of Bevy. So there's only 1 per app, and we increment by 1 tick every time the fixed update schedule runs. So generally in networking, you use tick to keep track of times, and games usually run at like 64 ticks per second. Then there's a remote timeline. So it's basically our best estimate of the time of the remote computer that we're connected with. And Lightyear estimates this by sending ping and pong packets like all the time. In these packets, each peer writes like their current local time. And so you use this with an averaging algorithm to estimate like the time on the remote timeline. There's the interpolation timeline. So basically, if you simply received a remote packet and use that to display and use that to update your world, your world would be updated in a very not smooth manner because you receive the packets not exactly every frame. You receive them like every 100 milliseconds. Some of the packets might be out of order. So what you need to do generally is keep a buffer of those packets and interpolate between the 2 consecutive updates that you received from the remote. And to do this, you need to be a bit in the past because you have to wait for the buffer to fill up. So that's what's shown here. The interpolation timeline is slightly in the past compared to the remote. And then the final timeline that's being used, and that's basically equivalent to the local timeline. That's the one that drives the Bevy time resource, is the input timeline. And this one is in the future compared to the remote because Lightyear wants to do prediction. So when you press on a button, we don't want to wait for a round trip where the input press is given to the server updates the world and sends some update back. And then once we receive the updates, we move our character. Now, what we want to do is that the moment you press on the button, your character moves on the screen. And then we send the input to the server. And when the server receives it applies that input. And for that to happen, you need to be ahead of the server. So when you press a button on tick 5, you send that to the server, and that message has to arrive on the server before the server does tick 5. So the input timeline has to be ahead by basically the round trip time, like half of the round trip time between you and the server. So that's why there's like all these different timelines, and Lightyear helps keep those in sync. And then there's extra components that basically let you add extra capabilities to each of the peers connected on the network. So there's, for example, message sending. So you can add message sender or message receiver for a given struct to be able to serialize and deserialize the raw bytes that you receive into actual structs that you can use. There's also replication. So replication receiver, replication sender. That's basically like sending the states of the ECS, so the components and the entities of your world, to the remote world. And then there's some extra components that can be added to enable prediction or interpolation. So on the right, I put a little code snippet of what it would look like to add a new peer to your app. So you can add each of these components. So you can specify that this is a client. There's the link that's used to send and receive the raw bytes. You have to specify the address, both the local IP address and the remote IP address. And then you can add replication, prediction, etc. And on the snippets at the bottom, that's how you would replicate an entity to some remote peers. So for example, this is an entity spawned on a server. And you can say, I want to replicate this to other clients, and you can specify to which clients you want to replicate. So this will be replicated to all the clients that are connected to the server. And then you can specify which clients are going to do prediction, which ones are going to do interpolation. And now I'm going to basically show you like how it works by walking through a couple of examples, to show you like how it looks like. Let me just slow down the video a little bit. So in here you have two clients connected to a server, and this client is the one moving first, and I'm showing all the timelines at the same time. So you're pressing a button, and this is the square on the predicted timeline. So that's why it appears first, and it seems to move first compared to the other ones. Whenever you press the button, some messages are being sent to the server that receives the button presses, and the server updates the state of the world using those messages. But you can see that the client has already updated the state of the world. That's prediction. Like you update it as soon as the button is getting pressed. And then the server sends the state of the world back to both clients. So you can see on the client 2 here in the past that red square is the replication timeline. So it's the updates that we receive from the server. And it's not very smooth. So as you can see, it's what I was saying earlier. Like we receive those updates every 100 milliseconds, sometimes out of order. And so that's why what we need to do is here that last square is the interpolation timeline. It's slightly in the past compared to the updates that we receive, but it interpolates smoothly between two consecutive updates so that on your screen, everything appears to be smooth. So that's what Lightyear enables you to do in a relatively easy manner. So now I'm gonna walk through some of the other advanced features that I was explaining, that I was talking about earlier. So one of them is visibility. So you can say that an entity is replicated to all the other clients of your network, but then sometimes it's useful to be able to say like replicate to everyone except those two players, and this is what visibility allows you to do. So there's two ways of doing this. One is you have this replication state component, and you can say gain visibility, lose visibility on your given like peer entity. And the other one is rooms. So rooms is kind of a persistent way of managing visibility where you can create a room entity. You add some entities to it, and you add some senders, like some peers to it. And the entity will be replicated to all the senders with which it shares a room. So that makes it like fairly easy to handle this kind of stuff. And this is what it would look like. So basically in this example, you have two players connected to the server, and those two players are in the same room. So they're always going to be visible to each other. But these little green dots are each like a unique entity. And these are added to the room only when they're close to a given player. So then that's what it looks like. When the player is moving, those entities get spawned and despawn very quickly. So each of them, when they get spawned and despawn, it's the server sending messages like, please despawn those green dots, spawn those green dots, and it's happening like all the time. So another thing that Lightyear enables you to do is client to server replication. And the reason why this is simple is because everything is based on components. So there's no logic that's really gated to the server or to the client. Like any peer that has replication sender added to it can have the capability of sending replication updates to the remote, which I think is pretty powerful. So this is what it looks like basically to enable client to server replication. So here I'm querying for an entity that has a client component, and I'm adding replication sender to it with like some extra parameters. And that's it. But then what happens when both the client and the server have this replication sender component? Because then they would each send updates to each other, and it would get confusing. So Lightyear under the hood tracks which peer has authority over a given entity. So there's always only one peer in the network that is allowed to simulate and send replication updates to the remote, and that's called having authority. And when you don't have authority, you cannot send these replication updates. So this is like pretty powerful. And I'm gonna give you two examples of how it can be used. So one of them is, for example, you want to replicate your cursor, like that you move on the client directly to the server. And this can be done simply by client-to-server replication. So here I'm moving the cursor on the client. The date and the state of the circle is getting sent to the server, and the server then replicates it back to the other clients. So this is what it could look like. But another thing that's pretty useful is that you can swap authority between different entities. So in this example, that circle here is an entity, and it's being replicated by all of the different peers on the network. So each of the peers have replication sender, and each of these are trying to replicate it to the other peers of the network. However, there's only one entity, one peer that has the authority over these components, and the authority is tracked by the color of the circle. So right now, when it's close to the green player has authority. And so you can see that it has authority because the green circle moves smoothly here because it's being simulated inside this app. And it's not smooth in the other two apps because it's just receiving replication packets. So it's receiving them every 100 milliseconds. That's why it appears not very smooth. And then at this point, when it's far, the server gets authority over entity, and the server now has a job of simulating it. So for these other peers, they're just receiving simulation packets. And then again, it moves towards the authority is given to that other client. And this can be useful, for example, in peer-to-peer games or in like more massive games where a client will be simulating the environment around them. Like if you have a huge world to render, it can be good to distribute the load of simulating the world between multiple clients. Another thing that Lightyear enables to do is compatibility with Avian. So Avian is, I think, one of the preferred physics library with Rapier for Bevy. And it's kind of tricky to combine networking and physics because there's a lot of things to be aware of. There's a lot of system ordering between prediction, interpolation, and physics that need to be tuned carefully. So Lightyear Avian is a plugin that allows you to do all of this fairly seamlessly. It syncs the necessary components and resources. And there's some extra things that it provides for you. For example, lag compensation, which is something that's needed for FPS games. So Avian has this like spatial query system param that can be used to cast array. And you can use the lag compensation spatial query, which has exactly the same API, but will deal with the timelines, apply like some interpolation delay to do lag compensation. So this is what it looks like to run Avian and Lightyear together. So this is like in a 3D environment this time, and yeah, everything gets replicated. I just wanted to show this example because there's also like this debug UI that I added that shows you the number of messages that are being sent, the amount of data that is being transmitted, the number of rollbacks that are happening during prediction. So it can be useful to debug if there's like any problem in your app. And lastly, what are some of the next steps? So one of the big next steps that I'm planning to do is to replace the replication logic. So basically everything that's handled by replication receiver and replication sender to use Bevy Replicon. So that's another networking library that's very popular and yeah, very impressive. And originally Lightyear had a lot more features, especially around visibility, around delta compression. You were able to replicate only one component, things like that. And yeah, Bevy Replicon has been adding all of these in the last year or two. So now, yeah, they're pretty similar in features. So I think, yeah, it's the right move to move Lightyear to use this library. And another thing I want to do is that most of the examples in the Lightyear repo are mostly for the client-server architecture. But as I mentioned, there's no reason for peer-to-peer examples not to work with the Lightyear architecture. So I kind of want to try adding examples using peer-to-peer. And yeah, that's it. So quick overview of how Lightyear works and what it allows you to do.
Wow, thank you so much. This was a lot, super interesting, and it's impressive how much Lightyear supports in terms of features. That's crazy. We got a load of questions, so let's start from the top. How does Lightyear perform with thousands of dynamic units on screen? Is the bandwidth usage optimized for this?
Yeah, I think it's fairly optimized. I haven't really tested with thousands of units, but I know that Replicon can handle this kind of load, and I'm going to switch to Replicon pretty soon, so it should be okay. But yeah, Lightyear does have some features that allow you to be careful around bandwidth. So like one of them is delta compression. I didn't really talk too much about it, but what it means is basically that if instead of replicating and serializing the states of your components, you're instead serializing the diff between your components and the version that you sent previously. So you're only sending a diff, which is a shorter amount of data. And another thing that can be used is you can send a maximum bandwidth that is available, for example, like 1 megabyte per second. And there's going to be like a priority scheme where you don't serialize the whole state of the world, but only a subset. And the entities that have higher priority will be sent more frequently, and the ones with less priority, for example, the ones that are far away, will get sent less frequently. So yeah, this can also be used too.
That's cool. All right. Next one. Are you aware of commercial games released using Lightyear?
I'm not aware of any. I think there are some that are using Lightyear, but maybe were not released. I think I've added them to the repo in the README. There's also an example, I think, in the Bevy Jam number 5, I released like a multiplayer game using Lightyear that worked pretty well, just to show like, that it can work in a real environment.
Nice.
Otherwise, there's no commercial game.
Does it work on WebAssembly, by the way?
Yeah, it works on web as well. Nice.
Okay. Do you compress data sent? I guess you already answered that. Delta compression, right?
Yeah, so delta compression is like compressing against the previous state, but otherwise, normally you could also compress the stream of data by applying like ZST compression, like some of the compression algorithms. This is not something that I do right now, but yeah, I kind of want to support it.
Do you think that's going to make a huge dent?
I think it's pretty important, yeah, because bandwidth is probably your biggest cost for a multiplayer game. Compared to like CPU usage, bandwidth it can be like a massive cost on games. So that's probably the most important thing to optimize for.
Yeah. Next one is, are you using Lightyear for a game project yourself? I mean, probably aside from the Jam game a few years ago.
Not really. I mean, the reason I started Lightyear was actually because I wanted to re-implement those kind of IO games myself, like Agar IO, like massive games where you can join without any login. And I couldn't find any way to do this in Bevy. So that's kind of what started this project. But now I kind of got sidetracked and I'm working more on Lightyear than the game itself. So
classic.
Yeah, that's something that I want to work on.
I mean, that's how Bevy started, right? I think we're in good company there. All right. With clients optimistically predicting the timeline, are conflicts possible where two clients optimistically take action which conflict? If so, how do you handle this?
Yeah, so that's the classic problem of prediction. Basically, that you're on your local client, you're predicting something, for example, that you were able to move, but the server knows that you were stunned, for example, by another weapon, and so you were not able to move. When that happens, you have something called a rollback. So basically, on your local client, whenever the server tells you you were wrong in what you were predicting, we roll back the state of the world and repredict all the frames between the remote timeline and the current timeline. And usually what I try to do is to smooth the rollback. So instead of like snapping back the state of the world to the correction, I do this smoothly over several frames so that it's not too jarring. And which I think is the standard thing to do.
Yeah, makes sense. Which begs the question, like everything is totally dependent on the input being properly hooked in, right? And you mentioned supporting Leafwing and the enhanced input. Is it like, it's possible, I guess, to extend it just with your own whatever input library you want to use, right? Or make it completely custom?
Yeah. So yeah, you can use Leafwing, Bevy enhance input, or send your own structs, like define your own struct or enum for your input.
Okay.
And use that.
Yeah.
But yeah, I would recommend using Bevy enhance input. I think it's pretty good.
Makes sense. Nice. The authority system for replication reminds me of Rust's ownership and move concepts. Are they related concepts in the code?
Not really. I think like authority is basically just like a Boolean flag right now that tells you like, do I have authority or not? And you can send in a message to say like, give authority or request authority from another peer in the network. Yeah, so that's, yeah, it's implemented like rather simply. There's no like link to ownership.
Yeah. Oh, this one's interesting. Do you think Lightyear will ever become upstreamed in the distant future?
I'm not sure. I don't really think so. I mean, at least it's not really a priority for Bevy. There's a lot of other things to work on, and something like networking. Like basically, the problem is that as soon as something gets upstreamed, it gets harder to make progress on it because there's a lot more eyes on it. The bar for a PR getting merged is very high, and yeah, sometimes it's actually the right move for a library to be to not be upstream and to remain third party for a long time so that you can make changes to it. And I'm also not really sure that Lightyear's current API is the one that I want to stick with. There might be like breaking changes in the future. So
Rewrite coming up.
I mean, there's already like the Bevy Replicon like the merge with Replicon, which is gonna change like quite a lot of things, I think. So
when do you expect that to land?
Not immediately, but maybe like in like 3-4 months, something like that.
Nice. Yeah, I mean, it really is a great testament of the modularity of plugins in Bevy, right? That we probably end up having like all these different backend implementations for what you mentioned, like WebSocket and UDP or whatever, which is already what Replicon builds on top of, right? And then you building on top of Replicon once this merge has been done. It's a really nice way to really pick and choose for the user.
Yeah, I agree. I mean, honestly, I think that sometimes, when you touch Bevy too much, as soon as you write Rust code that is not Bevy, you're suddenly lost because, in Bevy, all the lifetimes are kind of handled for you. You can query anything. Like everything just works magically. And it kind of like, ruins like normal Rust for you.
Yeah. I mean, perfect segue from the first presentation that we've seen. Like,
yeah, exactly.
I totally agree. Like, wait, I don't get my dependencies automatically injected. How do people do that? All right. How do you handle times potentially jumping backwards? I guess because you said you smooth over, right? So it could also be that it would require you to jump back when you keep ping-ponging.
Yeah, that's a good question. So for the timeline sync, what happens is that the time of the server is like the golden time that every peer network tries to stay close to. And it stay close to it by speeding up or slowing down your local time. So if you notice that you're like far ahead, you're gonna like start slowing down, and the speed is set to like 97% or something, or like slow. But sometimes there's like a big move, or you're suddenly like change connections, or like you switch to Wi-Fi, and you need to actually do a big time jump. And in this case, there's like an event getting emitted that changes your tick. For example, you can go backwards in time, and it's gonna look pretty jarring on your skin on your screen, but otherwise, there's not much that you can do, I think.
Yeah, I mean, I'm just curious about all these edge cases that are potentially possible when you do like the timeline is based on this ping-ponging. I mean, that could also mean that it takes a while until it's really like settling on something that's probably reliable, right? So I guess there's some warm-up going on before this is even used.
Yeah, like we wait for at least like 7 or 8 like round trips before using the value.
Yeah. Which goes hand in hand with the next question. How does it handle unstable network conditions, such as high packet loss?
It handles it pretty well. So actually all the examples, like in the link that I was showing earlier, there's here like a settings.conditioner. And the conditioner is basically to apply conditions on the link. So such as like packet loss, like a random reorderings of packets, things like that, latency. So usually when I test with a pretty like maybe 10% packet loss, 100 milliseconds of latency, things like that. And yeah, because all the packets are being buffered and you interpolate only between the received packets, like things would still look smooth even like in bad conditions. And you should always test networking in pretty bad conditions, because it's pretty easy to get things working with like 10 millisecond latency, no packet loss, and then have it completely change if you add a bit of latency.
Yeah. Yeah, that's a good point. I mean, it's good to be able to support that out of the box, right? And basically just by default have it like go almost worst case scenario. If you get it to work properly, then should be pretty safe.
Yeah.
What about like disconnects and stuff? Is that also, would that also be automatically handled and reconnect?
So you can disconnect and reconnect, but like you can do it manually. There's no like automatic handling for it. There's no there's nothing like we save your state or things like that. I think it could be, you know, like a third-party plugin that can like handle this maybe, but yeah, there's nothing like that added currently.
So the user would have to also implement themselves to have some sort of stable ID that that would actually identify this is actually the same person or the same client reconnecting again.
Yeah, correct. Yeah. Okay. I mean, Lightyear provides like a stable ID, but it's, yeah, Lightyear already provides some stable ID, or like you need to provide a stable ID sometimes for like Lightyear to work properly. But yeah, you will need to handle extra stuff like how do we restore the state for that given things like that.
Yeah. All right. Can a client become host and clients migrate?
Yeah. So basically, the role thing is completely dynamic since it's based on components. So you could have, you know, a client be a normal client, and then you add the server component on it, and it becomes both the server of the game for clients connected to it, and one of the clients connected to that server. So that's something that's possible. So yeah, that client basically becomes like a host client. So that's the component I added here, which is just a marker component. Is every time you see a client that's both a client and a server, then we add this. I think it's convenient, but it can be tricky to get right because there's a lot of edge cases in your queries to handle. So generally, another approach would be to have two apps running on the same computer and to use like a channel to send messages like instantly between them with no latency. And in that case, like, you know, the two apps are independent, so there's no extra complexity. But yeah, it adds more like CPU processing.
Interesting. So does it come with any sort of implementation for, I guess, IPC, or what are you suggesting here to do this communication?
Just like channels. So like one of the transports, like at the bottom, there's like web transport Steam, but you can also just use like Rust channels, like crossbeam channels to send data.
Yeah, but that wouldn't work across processes, right? Or how do you want to do that?
Sorry, yeah, two apps in the same process, but like different.
Okay. Interesting. Okay, we are almost at the end. Is there also a Rapier support? Is there a Rapier support library? Because I guess you mentioned you have a explicit support for Avian. How does it look for Rapier?
Yeah, there's no support for Rapier, mostly because I've never used it, and yeah, I'm not familiar with it. Also because it's easier to work with Avian because it's very tightly coupled with the ECS. Like everything is a plugin. You can order your systems against like Avian systems. But I think Rapier doesn't work like that. Like it's not that closely integrated with Bevy, so it can be harder to order like prediction interpolation with like Rapier's physics.
Yeah, I guess it's sort of like it's basically just bridging between like this non-ECS world and making those things available in the ECS, right? So,
yeah. I mean, it might be possible, but I just haven't. Yeah, I haven't looked into it.
But I guess you would be open for someone contributing it if it would come up.
Oh yeah, sure.
Nice. Okay, I think the last question you basically answered, like, does Lightyear require a dedicated server? I guess no. You said you could have a host client or whatever you called it, right?
Yeah, exactly. Yeah.
Yeah, and even dynamically change that. So that's pretty cool.
Yeah.
All right. Cool. Well, Periwink, thanks again. I mean, first of all, for this presentation, but obviously also for the huge effort on maintaining this huge library. And hopefully you will eventually get to the point that you can make use of it for this game project that you always wanted to do with it.
Yeah.
All right, cool. I will actually also get Promethea back on stage, and then we can maybe from the audience, there's going to be some more questions, more generalized questions. I would be curious to hear those. But yeah, thanks again for your presentation, and you too, Promethea. There was, I think, one question that I had left on the DI specific presentation. Where was it? Oh yeah, it was about the dimensioned systems parameter, like all the permutations that are prepared for the different amounts of system parameters, and I think it goes up to 16. So the question is, does that mean that's the limit, like in terms of parameter inputs for Bevy systems?
No, because essentially it works on tuples. So you can just put a tuple inside a tuple, and now you have unlimited parameters. It just gets kind of annoying.
Oh, yeah. Okay. So it's like cascading tuples then.
Yeah.
Well, if that's the case, why do we even need like all the different ones until 16? Shouldn't it be then like, I don't know, as soon as you support 2, you can support all the...
Technically, yes. It would just be because then it would be like open parentheses, first system, open parentheses, second system, open parentheses, third system, so on. And then you have like that many closed parentheses all in a row at the end. Not
I see.
Super fun.
Yeah. I get it. Okay. Well, as long as there are no other questions coming in from the audience, I would say my biggest question would be, is there anything planned in the future on these two different projects? I guess the dependency injection book, and in your case, Periwink after the Replicon support. What's the next big thing that you have in mind? Maybe you want to start, Promethea?
Currently, I don't have any specific plans for it. I kind of work on it when I have time and inspiration for it, and recently a little bit lacking in both. There are more topics, and I could maybe eventually expand to talking about how queries work or how automatic parallelization works and so on, but currently I'm focused on trying to build things more than anything.
Yeah, I see. But yeah, I think there was a question about the parallelization. I think this is definitely something that would be one of those, how the hell is this working under the hood, things that would probably enlighten a lot of people, like seeing a simplified version of how it actually works.
Yeah, I do think it's a pretty cool system. The funny part is just that half the time not doing it is faster.
Wait, you mean like explicitly running the Bevy feature of disabling the multi-threading, or what do you mean?
Yeah, that can actually help your FPS, because a lot of the time your systems just don't do a whole lot. So bothering to get all that overhead for multi-threading doesn't actually make up for anything. It just makes it more expensive.
Interesting.
It is a very interesting problem to have that no one checked for kind of a while, of like, oh, that's maybe not a good default.
Yeah, so it boils down back again, as usual, to benchmark, right?
Yeah, I know that Nth in the Bevy Discord has been working on a new scheduler that could maybe change things and make it good for default. I haven't heard about that super recently, but I'm pretty sure it's still in the works.
Okay.
If I remember correctly, the scheduler was called Forte.
What would be the big different approach there to make it
more
effective?
I think it was called a heartbeat scheduler, whereas Bevy's is a work stealing scheduler. I'm not super up to date on the differences. Work stealing is kind of an industry standard scheduler type. Whereas Heartbeat, I hadn't really heard of much and seems to work pretty differently. The idea is just that the Heartbeat avoids some of the overhead that work stealing runs into that causes it to be so poorly performing for a Bevy engine game workload.
Interesting. Okay. Well, it sounds like I should reach out to them and try to get them on stage to talk
that'd be
about
super
it.
cool. I'd love to hear about it. I think they already gave a talk about it too.
Sorry?
I think they already gave a talk about it too.
Well, perfect. Then it's not even much of preparation effort. Okay, cool. So yeah, I guess you're open for ideas. If people want to learn about something specific that would touch on the Bevy ECS, you would be reachable on Discord, I guess, or on your book's issue tracker, correct?
Yeah, both. Open to ideas. Not necessarily going to get to it because, of course, I do need time and inspiration. But
well, at least the inspiration part could be dealt with then.
Maybe.
Cool. Okay, Periwink, what's after Replicon migration on the roadmap for you?
I don't think there's anything specific on the roadmap, but there's a lot of open issues in the repo. I think I have more than like 100 open issues. So yeah, there's always things to fix and things to improve. Like all the examples that I showed are still like fairly simplistic, but in networking, there's a lot of cases that are pretty hard to handle. I think like moving platforms, lag compensating bullets that can like maybe hit a lag compensated platform. Like there's a lot of extra like edge cases that you can think of. So yeah, maybe like tackling things like that.
Yeah. Do you get a lot of contributions on Lightyear?
Yeah, a fair amount. Maybe
is there like if someone wanted to join and support you, is there like simple easy entry tickets or issues?
Not right now. Yeah, that's something I need to set up.
Nice. Okay. Well, one thing that I always like to ask is what is on the Bevy roadmap that you're excited about? Perry, do you want to start?
Sure. Let me think about it. I mean, there's a lot of things, honestly. Like the Forte thing, I had heard about it as well. I had checked the code actually. Like it's pretty impressive, and it's something that I've been waiting for because I think it would speed up, especially the parallelism for small and quick running systems. And there's some improvement around queries that I'm pretty excited about and that I was like working on. For example, like right now, when you want to query, you can only query a single entity. You query the components for a single entity, but there might be changes where you can query components for an entity and related entities. So like components from their children or things like that. Like basically traverse the graph of a given hierarchy. Yeah, so like things like this are pretty exciting.
So this would be encoded in your query then? Like you would say, hey, I want this component, but I want it also on a hierarchical like traversal of all my children or whatever generic relationship?
You would say like child of and then generic like query child of T, for example, and then query like those components from the child parent entity, things like that, nested queries.
Yeah, I think there's a lot of like exciting things that I see in ECSs outside of Bevy, like Flex and whatnot, that are supporting some more of those kind of things, right? Would be really cool to get more of that as well.
Yeah.
Awesome. Okay. Finally not the classic editor that's mentioned. All right, Promethea, what about you?
I hadn't heard about those nested queries, but I would be very excited to see that. That's something I've wanted every single time I do something related to relationships. It's like when relationships finally landed in Bevy, I was like, oh, great, this will make so much code easier. I mean, it's better, but like not as much as I was hoping because we need the multiple entity queries for it to actually be as good as Flex.
Yeah.
Other things are BSN, obviously. That's huge. That'll be very nice. And also UI improvements. I'd be very interested to see more stuff coming along for UI other than BSN to be a lot nicer to work with.
You mean like specific widgets or what exactly?
Widgets,
because there's a lot of improvements in the latest releases, right, in terms of UI.
Yeah, so widgets, reactivity, I think, is something they're heading
yeah.
towards. Stuff like that, just general improvements across the board.
Do you have are you up to date on what the current direction is in terms of reactivity?
Not completely. I've seen discussion here and there, but mostly I pay attention to like high-level engine development. I'm not as certain about what specifically is being worked on at all times.
Yeah, yeah.
Oh, actually, oh, sorry.
No, go ahead, Perving.
Yeah, let me amend my answer. I saw someone in chat mentioned many-to-many relations. That's probably actually the biggest thing that I need, because every entity replicated on Lightyear, there's like a relation telling like which client is it replicated on. And so I'm actually using many-to-many relations, because an entity can be replicated on multiple clients, and the client can replicate multiple entities. And right now I'm using kind of my hand-rolled implementation, which might not be as efficient as like something that Bevy would provide. So yeah, that's something that that I'm really waiting for.
Are you following I mean, I think there is like one or two proposed PRs on how to implement it, right? Are you familiar in like the terms of approaches?
Yeah, I've seen those PRs. Yeah.
Is the one that you hand rolled similar, or is it like
yeah, I think it's pretty similar.
I guess it's in the end somewhat of a pivot like entity in between that goes then in like both directions, end to end, or
not really. It's mostly that, you know, in current relations, the child entity has an entity that points to the parent, and the parent has a vector. And in this case, instead of a single parent entity, you could have like, I think, a hash map or a hash set of parents. So you could have multiple parents, something like that.
Yeah. Okay. Interesting. Making UI more read. Yeah, I'm just checking if there's anything in chat that I missed, because thanks for pointing that out. Okay, cool. And I didn't check yet. Since we just saw the release of Bevy 0.18, is it already up to date for Lightyear? Like, do you already support that?
Yeah.
Nice. Was there any change that affected Lightyear for like really?
Not really. I mean, the problem is that I have to wait for all the other dependencies to release. I have to wait for Avian and like a bunch of other packages. So yeah, it takes a bunch of time.
Happens every time.
Yeah.
Although, I mean, Avian was pretty quick, like not doing the whole feature release, but just like a Bevy support release. That was pretty early this time. So
Yeah.
what other big dependencies do you have? You mentioned the input dependencies, right?
Yeah, the input dependencies. There's this
right now you're on like the different transport layers, I guess. That you support?
No, there's this grid called Aeronet, which was introduced maybe a year ago, which is really, really good, and which handles basically like the logic of handling WebSocket, web transport, like all these different transports.
Okay.
Yeah.
And that's probably not Bevy specific even, right? So it isn't affected by Bevy releases, I guess.
Oh no, it's Bevy specific. It's like Bevy.
Okay, I see. Awesome. Yeah, I don't think I have any other question. Let me quickly check if there was anything else coming up from the audience side. Nope. So yeah, thanks again, you two. Is there any question that I should have asked that you want to ask the other?
I'm good.
Yeah, same. Oh, and thanks for hosting.
Awesome. No, thanks for you guys really taking the time. This is obviously not an easy ask to do on busy schedules, to present and prepare presentations like this. So it's really appreciated, and thank you so much. And yeah, I'm gonna close this one, and hopeful that people step forward, maybe Nth for the aforementioned presentation for the future. But if you have any other candidates that you want to pitch me to, just reach out on Discord. Give me hints of who I should poke, and I will try to get more interesting content up on the meetup.
Yeah, cool.
All right, big hands from the chat again for the amazing speakers and presentations, and thank you so much.
Thanks.
All right, let's close it up here. Yeah, you see the stream. You can see the recordings coming up pretty soon on the YouTube channel as well. To stay up to date with upcoming meetups, please go to bevygamedev.com and subscribe to the meetup group there. And yeah, thanks for being here, and happy new 2026 for Bevy.